Hello students, let us get started with another new concept, that is concept of heat and work. First let us see what is meant by heat. As we know that heat is one of the forms of energy and heat can flow from one body to another body, or I would say it is one of the ways by which energy transfers from one body to another body depending upon the difference in the temperature of the two bodies. Okay, and that is why heat may be defined as the quantity of energy which flows between the system and surrounding on the basis of temperature difference. To understand this definition easily, let us see an example here. The red colored object and slightly blue colored object. Red colored object is a hot object and it is a cold object. When we say hot and cold object, means the temperature of the object, which is if the temperature of the object is high, that is said to be hot object, and which is having the less or low temperature, which is said to be a cold body. And if the two bodies are connected through the conductor, obviously everyone know that the heat flows from hot body to cold body. Okay, hot body to cold body because of the temperature difference. And this term heat is a state function but not a path function. Let us discuss what is a state function. State function is nothing but the property which only depends on its initial state and final state during the process. That property is called as a state function, and the property which depends on the path by which the process proceeds. Suppose let us take an example, one process which is being carried out by two ways. In the first way, if the property is the difference between the property is x, and in the another path, if the difference between the two states, the property is different, then that property is said to be a path function but not the state function, because that property depends on the path through which the reaction proceeds. That is why it is said to be a path function. And state function means, since heat is not, we are saying heat is not a state function, obviously that means heat is a path function. If we change the path of the process, then heat change also changed. That is why it is a path function, and it is an extensive property. Just in the previous class we have discussed what is meant by extensive property. Since we are saying heat is an extensive property, that means the heat depends on the quantity of the substance. Means greater the quantity of the matter or substance, or we say system, then greater would be its heat content. Okay, that is why it is said to be an extensive property. Means it depends on the quantity of the substance, and heat always flows from high temperature body to low temperature body. The units of heat. As we know that heat is measured in terms of calorie as well as in terms of joule. Calorie is the unit, SI unit, and which can be defined as the quantity of heat needed to raise the temperature of 1 gram of pure water by 1 degree centigrade. Suppose you are provided with 1 gram or 1 ml of water, because 1 ml of water is equivalent to 1 gram of water. 1 ml of water, and if you are asked to raise the temperature, increase the temperature of that 1 ml of water by 1 degree centigrade, how will we increase the temperature? By providing the heat. Then how much quantity of heat is required to increase the temperature of 1 gram of pure water? That amount of heat is called 1 calorie. Okay, let us try to understand. Means to increase the temperature of 1 ml of pure water by 1 degree centigrade, how much quantity of heat is needed to be provided to that water? That is nothing but the calorie. And as we know that 1 kilocalorie is equal to, that kilo stands for 1000. 1 kilocalorie is equal to 1000 calories. And okay, and the another unit of heat is joule, which is named after the British physicist Joule himself. Another unit is Newton meter also. 1 calorie is equal to this the simply convergence of one unit to another unit. 1 calorie is equal to 4.186 joules, and 1000 joules is equal to 1 kilojoules. Joule is the most common unit which we frequently use to express the heat. Since it is a very small, it is very convenient to use the joule as a unit of heat. Okay, the next is sign conventions of heat. Means during the process, sometimes heat is denoted as a positive, heat is denoted by a positive symbol or negative symbol. What is that? Is nothing but the sign conventions of heat. Heat is represented by a symbol, small letter, small alphabet Q. If heat flows from system if heat flows from surrounding into system, to raise the energy of the system, it is taken to be positive. Or simply just remember, during the process, if heat is absorbed by the system from the surrounding, then that heat is denoted as a positive, or that heat is taken as a positive heat. Okay, plus Q. Okay, means suppose when reaction is going on or the process is being carried out, during the process, obviously system changes from one state to another state. During that change, if the system absorbs the heat, as we know that there are some reactions which proceeds only after absorbing the heat energy, or the heat energy is absorbed to push the chemical reaction to occur. In such reactions, during such processes, heat is being absorbed, so absorbed amount of heat is represented as plus Q. And sometimes there are certain reactions which evolves the heat during the process. These processes, or the amount of heat evolved during the process, is taken as minus Q. Okay, we take the heat as plus Q and minus Q, depending upon whether the heat is absorbed during the process by the system or heat is evolved during the process by the system to the surrounding. Okay, remember one, from surrounding to system, the transfer of heat from surrounding to system is taken as positive, and the heat flows from system to surrounding, it is taken as negative Q. Okay, absorbed heat, in short, absorbed heat positive Q, evolved heat negative Q. And we know that 1 minute, it is not okay. The process in which heat is absorbed, it is called as endothermic process, and the process in which heat is evolved, that means heat flows from system to surrounding, such processes are called exothermic process. Endothermic process, heat absorbed, positive sign. Exothermic process, heat evolved, heat is given out from system to surrounding, that is taken as negative. Okay. Now another concept is work. As we know that work is another form of energy, and work is one of the ways, one of the modes of transfer of energy from one's body to another body, or let us say it is one of the means by which the system can exchange energy with its surrounding. Okay, during the process, system exchanges energy with the surrounding. By doing that, system does some work. That is the whole idea about the work is one of the means by which the system can exchange energy with its surrounding. If you look at these pictures, physics concept of work means the mathematical expression of work. How can we express the work in a mathematical form? That is given as like this. To understand this formula, let us see here. The one person is pulling this cart, okay, and to pull, as we know that to pull or push anything, we need a force to apply on that object. Okay, he is pulling that cart. Where is the cursor? Okay, he is pulling that cart, okay, and he pulled that cart by a distance of, suppose, yes, okay, and to pull that cart to the distance of yes, he or she has applied the force on the system, and that is taken as F. Okay, force applied on the object to carry that, to travel the cart up to the distance of yes. Okay, then we may say that work is done. Some work is done, and that is mathematically given as W is equal to F into S, or mathematically it is given as W is equal to F into S, where F is the force applied on the object to travel the distance by S. Okay, sometimes the mathematical form of work is also given as W is equal to F into dl, where dl is the small distance, the distance traveled by that object or traveled by the system. Okay, instead of S, sometimes it is taken as dl, small d, small l. That is nothing but the total distance traveled by that system so as to acquire some quantity of work after applying the force F. Okay, the SI unit of work is, again, it is joule. Work and heat, both the terms, both the concepts are expressed in terms of joule. Okay, the unit of both work and heat is joule. The sign conventions. Similarly, the heat, if heat is absorbed, it is taken as positive. If heat is given out, it is taken as negative. Now let us see about the sign conventions of work. Okay, system does work, or the work is done on the system. There are two types of it. What is that? The work is denoted by a symbol W. If work is done on the system by the surrounding, and the energy of the system is thus increased. Okay, here in this picture, that man was applying the force on the cart, means the cart is the system, the work is done on the system, he is applying the force, means he is transferring his energy to the system. When we say work is done on the system, at that time we need to apply force on that system. That means we are transferring the energy in the form of force to the system. Automatically the energy of the system gets increased. Okay, work is done on the system, then energy of the system increases, therefore it is taken as plus W. Okay, now if work is done by the system itself, okay, there are some reaction which takes place on its own by applying its own energy. In such cases, we say that the work is done by the system on the surrounding, and energy of the system is decreased. Why it decreases? Why it gets decreased? Because system utilizes its own energy to perform the work. That is why its energy steadily, as the reaction, as the process proceeds, it decreases. That is why it is taken as negative work. This is the summary of the sign conventions of heat and work. Heat flows into the system, positive. Heat flows out of the system, negative. Heat flow, it is not heat. Work is done on the system, work is positive. work is done by the system, work is negative. Sorry,